Alright everybody, today we're going to be doing some half cell potentials and cell voltage, which is a SA2 material that is covered, and it is found on page 432 in the blue Barron's review book. You will also need to see table Z, which is located in the appendix towards the back. So when we do half cell potentials, what these are is an actual measurement of electricity that we can determine inside of a battery, which means the potential difference, which is voltage, which we refer to as the term volts. So every half reaction that we do has its own standard voltage potential. So for example, the more positive the number for your voltage, the easier your reduction half reaction will occur. And when we talk about our standard oxidation potential, these are going to be the reverse values of the standard reduction potential. Now, if you're a little bit confused, let's all turn to page 506 in the blue review book. When you turn there, you'll notice that you see a table called table Z, and table Z is going to show you all the different types of half reactions and their different potentials. So if you notice, for example, gold ions, when they gain 3 electrons, turning into neutral gold, their reduction potential is 1.5 volts of electricity. However, if you notice, they don't show you an oxidation potential. So instead, it's the reverse. So that means neutral gold, when it decomposes and breaks into its ions, then you'll notice it's losing 1.5 volts. So when we're doing calculations with batteries, your whole total cell potential is going to be the difference between the voltage produced from the reduction minus the voltage produced from your oxidation. The difference tells you the voltage produced from the battery, or how many volts the battery can release. So let's look at this little tiny question. Here we see a voltaic cell, and on the left-hand side you're noticing one of your electrodes is iron, and on the right-hand side your other electrode is lead. And you're noticing in the half reaction on the left you have iron ions, and on the half reaction on the right you have lead ions. You have a salt bridge connecting the two, and you have a load up top. So, looking at this reaction, you have to be able to identify with table J who is the more reactive metal. From that, you should be able to show the flow of electrons from electrode to electrode. Don't forget effort. Then you have to be able to write the half reactions that are occurring in each cell. That's using table J to see who is being oxidized and who is being reduced. Then, you have to figure out who is going to be gaining mass and which electrode is going to be losing mass. Then you should be able to calculate the cell voltage from the previous formula that I just showed you. And, thinking outside of the box, if you can calculate number 5, then if you have 4 of these, or 4 of these different voltaic cells, how many volts in total can you produce? That is your homework for tonight. I'll be checking that in class tomorrow, and if you have any questions, I'll be glad to go over with you guys.